So here's the question. The question is to write in the form of a plus b root 3 the following expressions. So I want to see if you've done it correctly. So you wanted me to work these problems right here, and I'm going to start off with the very first one, which is problem number 4. All right? So let me get my pen ready. We want to work this question right here. Number 4. So it says here, write the square root of 1/7 in the form of k to the times root 7. Going back to number 4. We want to write the square root of 1/7. And we want it in the form of k times the square root of 7. Now, if you look under the square root sign, of course, you could see the 7 is in the denominator. What we would like to be able to do is to move the 7 to the numerator. So what we can do is, we could say, take 1/7 and then multiply it by 7/7. If I do that, then I'm simply multiplying by 1. So then that becomes, so why did I do that? Is so that what will happen is that in the denominator I'll have a square, 7 squared, and I could remove the 7 squared outside of the square root bracket. And then on the numerator I will have 7 in the top. So then that will give me the opportunity to be able to express the value as k times root 7. So now this becomes the square root of 7/49. Now you know 49 is a perfect square, and so therefore I could write this as the square root of 1/49 times the square root of 7. So you see the square root of 7 part, which is this piece right here, and the k part, which would be this piece right here. So what's the square root of 1/49? Since 49 is a perfect square and 1 is also a perfect square, then that would simply be 1/7. The 7 sevens are 49, and then I am left with root 7. So now my k value is the 1/7, and then of course I now have root 7 right here. So the answer to this question is 1/7 square root of 7. Does that make sense? I hope it does. And that's the first question, question number 4. Now let's look at question number 5. Question number 5, part A. So 5A. 5A requires that we write in the form of a plus b root 3, a plus b square root of 3. That's the form that we're looking for. And so the very first question, part A, is root 3 over 2 plus 1 and 1 minus root 3 over 2. 1 minus root 3 over 2. So let's just rearrange this slightly so that the value with the radical is on the right and the constant is on the left. So that's the same thing as saying 1 plus root 3 over 2 divided by 1 minus the square root of 3 over 2. Just to make it kind of look, consistent. Now, if we want to, in this case, simplify things, we should multiply the top and bottom by the same value, but value in such a way that it will give us the denominator as a constant without radical, and the numerator can have the radicals. So if you look at the denominator, we have 1 minus root 3 over 2. So if we use a difference of squares, then it will help us get rid of the of the radicals in the denominator. So I'm going to actually multiply this by 1 plus root 3 over 2, 1 plus root 3 over 2. So, Zamani, that's where we're applying the difference of squares. And so with the denominator, when we multiply these two values right here, what will happen is that the root 3 over 2 times root 3 over 2 will get rid of the radicals for us. So this will give us, in our numerator, we will have basically a square, a plus b squared. But in the denominator, we'll get rid of the radicals, all right? So let's see what we get when we take the numerator and we square them. 1 by 1 is 1 squared, right? I'll just put it there just so that you can see it. And then we're going to have 2ab. Well, so it will be plus 2. What is a? A is 1, and b is root 3 over 2. So 2 times root 3 over 2. No need to write in the 1. And then b squared will be root 3 over 2 times root 3 over 2, which will basically give us root 3 squared over 2 squared. So I'm just going to put it all out so that you could see the money. And then the denominator, we have difference of squares, so it will be 1 squared minus root 3 root 3 over 2 squared. All right? So root 3 squared over... Actually, let's do the whole thing like this, root 3 over 2 squared. I should have done the same thing with the numerator, but that's okay. All right? So now let's simplify this. 1 squared is 1. So that would be equal to 1 squared is 1. And then we would have 2 times root 3 over 2. But if you notice that 2 is in the numerator and then we have a 2 in the denominator, so they will cancel out each other, which will just give us plus root 3. And then root 3 squared is 3. 2 squared is 4. So that gives us 3 over 4. All right? The 2 squared is 4. Root 3 times root 3 is 3. And then down here, we will have 1 squared is 1 minus root 3 squared is 3. 2 squared is 4. So that is also 3 over 4. All right? And now let's simplify that. What do we have? We will have the 1 in the numerator added to the 3/4 in the numerator will give us 1 3/4. And we have the root 3 plus root 3 divided by the difference between these two numbers. 1 take away 3/4 is a quarter. All right? 1 take away 3/4 is a quarter. Now, to get rid of the fraction a quarter, we could simplify that by multiplying the top and bottom by 4. I'm sure you'll agree with me on that. So let's simplify that even further. So I'm going to express, first of all, the 1 3/4 as an improper fraction. So it will become 7 over 4. 7 over 4 plus root 3. 1 over 4. And I'm going to multiply the top and bottom by 4 because I want to get rid of that quarter in here. So when I multiply the top by 4, 7 over 4 multiplied by 4, the 4 is cancelled out, which will give me 7. And 4 by root 3 is 4 root 3. And then 4 multiplied by a quarter, 4 quarters give you a whole, which is just 1. And so therefore my answer will be 7 plus 4 root 3. So answer 7 plus 4 square root of 3. So now we have it in the form A plus B root 3, in which case A is 7 and b is 4. Okay, so that is question 5a. Let's do question 5b. Okay, this next question is 5b. 5b. So here's what we want to do. We want to simplify as well in the form of a plus b root 3. So what we have is these two fractions, 2 plus root 3 over 2 minus root 3. And I'm going to leave some space, so I could put the expressions that I'm going to need to simplify them. 2 root 3 over 2 plus root 3. Cool. So that's a fraction. Now, what we're going to do to kind of get rid of the radicals in the denominator is to use the difference of squares. So if I multiply the denominator by 2 plus root 3, then I have difference of squares. A plus b times a minus b is a difference of squares. And then we will have the difference between 2 squared and root 3 squared. And when we square the 2 square roots, we will get rid of the radical. So in this case, we will multiply. Let me just put these things in brackets. We'll multiply this by 2 plus root 3 divided by 2 plus square root of 3. All right? And then we do the reverse on the next side, which is multiply by 2 minus root 3 over 2 minus root 3. And what that is that gives us difference of squares on the other side as well. It's okay to have the radicals in the numerator, but we want to get rid of them in the denominator. And so this very first one, if we look at it, what we will have is a plus, this here is now squares, a plus b squared, right? So we're squaring two similar terms. So a plus b squared we know is a squared, which is 2 squared, plus 2ab, 2. And what is a? A is 2. What is b? Root 3. 2ab plus b squared. Well, what is b squared? B is root 3, so that's root 3 squared. And then divide that by the difference of squares, a squared minus b squared. Well, what is a squared? It would be 2 squared. And what is b squared? Root 3 squared. On the other side, we will have root 2 times root 3, times the numerator, which is 2 minus root 3. If we multiply that, we get 2 2s of 4. So that would be 4 root 3. And then 2 root 3 times root 3 will be 2 times root 3 squared. Okay? Over. And then again we have difference of squares, which is 2 squared minus root 3 squared. Excuse me, we can simplify those. Over here the numerator would be 4. 2 2s of 4. So plus 4 root 3. And then root 3 squared is just 3 plus 3 over 2 2s of 4. Take away 3 because root 3 squared is 3. Minus 4 root 3. And then we have 2 times root 3 squared. Root 3 squared is 3. 3 2 is 6. So that would be minus 6. And then that would be over 2 2s of 4 minus 3. So in this case, both of the denominators will be 1. So simplifying that, excuse me, what we have is 7 plus 4 root 3. And because the two of them have the same denominator, we could put them all together in one single numerator. So the negative multiplied by this negative, multiplied by each term. Okay? So I will take the negative and multiply it by each of these terms. And then so negative 4 root 3, and then negative by negative 6 would give me positive 6. And 4 minus 3 is 1. The denominator is just 1. 4 minus 3, 1. So in the end, what happens is that the 4 root 3 cancels out with this 4 root 3. We have 7 plus 6, and the answer is 13. Answer 13. Okay? So I want you now to pause the video and go back and work this problem by yourself and then compare it to the solution that I have. So that's question number 5. Question number So question number 6, we are told to find x and y contained in Q such that 3 plus x root 5 times root 5 minus y is equal to negative 13 plus 5 root 5. So that is the case where when we have, I believe it is, let's see here if I could remember what that case is a case where you have, say, something like, say, x plus some value, let's say 3 plus y plus, if I don't know, 5 root something. Let's just say root 7 as an example. And if you have that is, say, 4 plus 6 root 7, what will happen is that the x plus 3 would be equal to 4, and the y plus 5 would be equal to 6. That's the model that we're going to use with working this problem. Okay? Good. So I'm going to take this out, and so I could have just a clean sheet for me to work with. Let's see if I could get rid of this. There we go. All right, so here's what we are working with. We have 3, sorry. So that's question number 6. We have 3 plus x root 5 times root 5 minus y is equal to negative 13 plus 5 root 5 plus 5 root 5. Now notice how we have the root 5 on the right in the first expression, but we have it on the left in the next expression. We have it on the right again. It doesn't really matter, but if it makes you feel more comfortable, you could always rearrange it, such as 3 plus x root 5 times negative y plus root 5 is equal to negative 13 plus 5 root 5. So on this side, we have no variables, no x or y. So we want to get the left side into the form that we could equate the two sides, okay? So what we have to now do is to do the expansion. And when we do the expansion, we'll get the following. So let's see the expansion that we get. So we will have, let's take the 3. 3 times negative y is negative 3y. Negative 3y. And 3 times, so I'm basically multiplying like this, and then multiplying like that. And then I will use this term times this one, and this term times that one. All right? So we're doing the expansion. So negative 3y plus 3 times root 5. And then we're going to multiply x root 5 times negative y, which will give us negative xy root 5. And xy times, x root 5 times root 5 would be plus 5 times root 5 squared. All right? And let me make sure I got this correct. I should say, that's not 5 times root 5 squared. I'm sorry. It's x times root 5 squared. Let me take that out. So that would be x times root 5 squared. And that's equal to what's over on the right-hand side. We're not going to do anything with the right-hand side just yet. So let's rearrange these formulas in terms of what has the root 5 and what that doesn't have the radical. So this will have the radical. This will have the radical. We will get rid of the radical by squaring 5. So that becomes 5x. So we'll have negative 3y. And then we have positive 5x. So let me just put the x first, because I like to put x before y. Okay? Not a big deal, but I like to put x before y. So this part right here will become 5x. Right? Become 5x. Now minus 3y. And then we will have, we have this 3 right here, and the negative xy. So that then becomes 3 minus xy root 5. So let's put that in brackets. I'm factoring the 3 over here. Let me show you in red. I'm factoring the 3 and then the xy from this expression to give me 3 minus xy root 5. And then I'm putting those two together as one block, and then we're adding them. So this is what we have. This is what we have as our expression, and that is equal to negative 13 plus 5 root 5. Okay? So basically all I did was the expansion, and then I rearranged the terms so that I have this expression right here. So notice I have xy in here, and I have 5x minus 3y in here. So it would mean that this term would be equal to negative 13, and this term right here would be equal to 5. Good? So let's see what we do with that information. Now, because xy is kind of funny, it makes sense to kind of express, to find out what xy is. So why don't we do that? So let's take this part of the expression. We will say 3 minus xy is equal to 5. And therefore, negative xy is equal to 5 take away 3, which is 2. Xy is equal to negative 2. All right, now why did I do that? I did that because then now I could turn around and use this value of xy in the expression up here. Okay, so I know xy is equal to negative 2. I also know that 5x minus 3y is equal to negative 13. So we're going to use that information. Let's put this over to the side. Let's squish that and put that over here. Okay. So we do know that 5x minus 3y is equal to negative 13. What can we do with this? Well, if we could express from over here x in terms of y, or y in terms of x, we could substitute in this formula. But an easier way to do it is just to multiply both sides by x. I'm going to multiply this side by x and this side by x. Why am I doing that? Because then I'll have 3xy, and then I know the value of xy is negative 2. I could substitute for xy and get rid of the y out of the expression completely. So I will just have an expression in terms of x's. So now I have 5x squared minus 3xy. So you see, now that I have this xy, I could use the value of xy equal to negative 2. And equal to 13 times x, so negative 13x. Because remember, I multiplied both sides by x. So substituting for xy is equal to 2, what do I have? I have 5x squared minus 3 times negative 2 is equal to negative 13x. So that will give me, simplifying that, I will have the following. 5x squared, negative 3 times negative 2 is plus 6 is equal to negative 13x. Bring it over to the other side. What do I have? 5x squared plus 13x. The negative goes to positive. Plus 6 is equal to 0. And now I must factorize. I must factorize that expression. So remember when I showed you factorization, I said to you, put the two factors here so I could do, for example, 5 and 1, because those are the only options. But 6 could go 6 and 1 or 3 and 2. Now if I go 6 and 1, either I have 6 5s are 30, and then I have 1 times 1. That doesn't seem to do it. If I go 1 and 6, it will be 6 plus 5, which is 11. That's not what I'm looking for, I think. But if I go 3 and 2, I could go 2 times 5 is 10. 3 times 1 is 3. 10 plus 3 is 13. So I should go like this. 2. So when I cross multiply, since everything is positive, 5 2s are 10 plus 3. So then in that case, what I'm getting is I could factorize this as 5x plus 3 times x plus 2 is equal to 0. In which case, x can be equal to negative 2, or x can be equal to negative 3 over 5. Okay, so using x equal to negative 2, we could find the value of y. So since we know that xy is equal to negative 2, and if x is equal to negative 2, then that means that y must be equal to 1. So it would be substituting in the formula, I'm going to substitute for x. So negative 2 times y is equal to negative 2, which would mean that y is equal to negative 2 over negative 2, which is equal to 1. So an answer for this question would be x is equal to negative 2, y is equal to 1. Okay? And that's the answer that the book has. I'm not sure why they decided not to go ahead and then just give us if we use x is equal to negative 3 over 5, then figure out what y is. So let me see if we did that. If x was negative 3 over 5, so you have negative 3 over 5 times y is equal to negative 2. So that means if I cross multiply, 5 2s 10, negative 10. Okay, negative 10. So y would be equal to negative 10. If I bring the 5 over to the other side and I divide by negative 3, so it would be y is equal to negative 10. Sorry, it would just be 10 over 3, not negative 10 over 3, because the two negatives cancel. 10 over 3. Okay? Now, I believe part of the problem, why they only chose this answer, is because it is said that x and y must be contained in Q. And I believe Q, from the definition that we were discussing earlier, have to be a set of rational numbers. And maybe 10 over 3 is not a rational number, because a rational number is a number that could be expressed as a ratio of two whole numbers. Although I see here we have two whole numbers, which is 10 over 3. So to me, that is a rational number. And then -2 is also rational. But I'm not sure why the book only gave a single answer. Anyway, if both of them were possible, then that would be the answer that you can use. All right? Okay. Here we go. So yes, I think Q represents a set of all rational numbers. So the question is, if 10 over 3 is not a rational number, then in that case we only use the values of x equal to -2, y is equal to 1. Okay? Good. And now for question 7. We're told to do a binomial expansion of a plus b cubed to write 5 plus root 2 cubed. So question 7, we want 5 plus root 2 cubed. Now binomial expansion cube would be 1, 3, 3, 1. From thinking of Pascal's triangle. So it would be a cubed plus 3a squared b plus 3ab squared plus b cubed. So if we use that as our guide, so let's write it down in terms of, so it would be a cubed plus 3a squared b plus 3ab squared plus b cubed. So a is 5 and b is root 2. So that would be 5 cubed plus 3 times 5 squared times root 2 plus 3 times 5 root 2 squared plus root 2 cubed. Okay, so that becomes 5 by 5 by 5, 125, plus 5 squared is 25. 25 plus times 3 is 75 times the square root of 2, plus 3 by 5 is 15, but root 2 squared is 2. So 15, 3 5 is 15, 15 by 2 is 30. Okay? Plus, now when we look at this, we could actually make this 2 times root 2 squared. Sorry, I mean root 2 times root 2 squared. But root 2 squared will give us 2. So that's the same as saying 2 root 2. Okay? So that's how we would simplify that, 2 root 2. And so, if we simplify now, this could be added with this value. This could be added with this value, which gives us 155 plus 77 root 2. And that's the answer. So that was a simple one. Okay? So there you have it. Pause the video and then try it on your own. Great. So let me now take this and save it.